Good morning, good day, and good afternoon to our audience listening in from around the world. Welcome to today's BSI webinar entitled Stopping Counterfeit Parts. In an effort to minimize background noise, we have muted all phone lines. As always, we encourage questions and comments throughout the presentation using the chat box located on the left-hand side of your screen. This applies to any technical assistance you may need, as well as submitting questions which will be answered at the end. All of today's participants will receive a link to enroll for a recording of today's event. Lastly, we ask you to participate in a brief survey following the web conference. We appreciate feedback and suggestions to improve our future conferences. Before I turn it over to our presenter, allow me a few moments of introduction. Today's webinar will be led by Brendan Hill. Brendan has been in aviation and engineering for 40 years, including 26 years as a British Army officer and aircraft engineer. He has been in business assurance and certification for 10 years, 4 of which with BSI, where he has developed BSI's quality management roles and theaters of operation in the aerospace sector. And now let me turn it over to our presenter.
Hello everybody, welcome to this presentation on counterfeits and unapproved parts. I hope you will find it interesting. It's a massive subject, so obviously we're going to look at it at a fairly high level. As was said earlier on, if you can keep any questions to the written side of things, that would be appreciated. I'm very happy to answer questions at the end. So we're going to start with a quick introduction on BSI very briefly. So a quick introduction to BSI, then look at counterfeiting and the scale of the problem. We're going to cover prevention, detection, some sources of information, and then finish off with best practice. So, the British Standards Institution, we've been around for a long time. We formed in 1901 and we were the world's first national standards body and we're a founding member of ISO. And we've been instrumental in developing well over 37,000 standards, including 10 of the top 12 business standards, such as 9001, 14001, 45001. I know many of you will be familiar with many of those. And we operate globally. We've got 3 regional hubs. So wherever you are, BSI is also there to help you. Examples of some of the standards that we wrote, BS 5750 became ISO 9001. ISO 14001 started off as BS 7750. Information Security 27001 started off as BS 7799. So you can see that we really are innovators and at the heart of business assurance and business excellence. And one of our more recent standards is Organizational Resilience, BS 65000, which is a relatively new concept in building resilience into all organizations. And it's worth noting that the International Aerospace Quality Group, the IAQG, has bought into organizational resilience and is using it at a strategic level. So BSI's value streams, we have standards, as we said. Certification, we provide certification services to all the main standards, including the aerospace series, the AS9100 series. We provide training in standards, in tools and techniques. And we have independent parts of BSI which provide consultancy. And there is also a stream of BSI which does product testing. And we use the universal symbol of the kite mark, which you can see shown there. So that's a trust mark. So any products that require testing, BSI can do that, and you can have a trust mark. So that's a brief trot through BSI. Onto the business of the day, counterfeits and unapproved parts. Just how big a problem is it? Well, let's have a look. EASA has a website on which it lists reports of unapproved parts and counterfeits. Now, so far in 2019, there are 22, which isn't a great number, but it's more than in 2018. Most of those are for Antonovs, but some are for A380s, and some are for multiple applicabilities, so several different airframes. So it doesn't sound very much, really, on the face of it, but here's the question. Does it follow the 80-20 rule? I'm sure everyone's familiar with this concept. And the question is, are we detecting 100%, or are we detecting 80% and 20% get through? Or are we only really detecting 20% and there's 80% that are not detected? So there's the numbers that are detected and then the numbers that are reported. Who knows the ratio? The fact is nobody knows. But let's look at some of these questions, some of these points. It's been stated that 15% of all material parts bought by the US military are counterfeit, not just aerospace. But that's an estimate because they don't really know. The Semiconductor Industry Association estimates that counterfeit PCB components cost manufacturers more than £7.5 billion annually. So that gives it some scale. How many PCB components can you buy for $7.5 billion? So if that's happening annually, how many of those are getting into the aerospace supply chain? So it begins to give us an indication of scale that may be applicable to our supply chains. So we need vigilance, attention. Every one of us, everywhere in the supply chain, at all stages, has to be vigilant and aware of the issues. This is a very interesting statement. The procurement process has become a main entry point for counterfeits due to, and look at each of these points, the use of unapproved suppliers, lack of part authentication procedures, lack of communication and cooperation between suppliers and customers, insufficient inventory control procedures, and limited counterfeit avoidance procurement practices. And we're going to look at all of those. So that statement really encapsulates the problem. Every company needs to assess its risks and consider what steps it should or should not take. This is slightly old data, but again, it's to try and give some scale. So in 2008, local law enforcement agencies looked at SUPs, and there were 2,468 suspected unapproved parts reported to the FAA. And there were numerous criminal indictments, criminal convictions, lots of jail time. Nobody wants jail time. Lots of probation time, but look at the costs involved, millions of dollars. And that was 10 years ago. So obviously the cost will be significantly greater. And here are some other examples that show the problems and how it can affect things like national security. GPS oscillators are used in 4,000 navigation systems. So you think about those being put into submarines, ships, fighter aircraft, weapon systems. How about autonomous drones? Makes you think. Self-locking nuts used on aircraft braking systems. Titanium used in fighter aircraft engine mounts. And the most amusing one, perhaps, brake shoes made with seaweed. And there are others we could cite, such as a Chinese electronics company that somehow managed to get its parts into the supply chain, and it ended up in military helicopter engine management systems. There was a crash in 2011, and when it was investigated, it was found that the computer chips in the engine were counterfeit. Now, it didn't contribute to the accident, it has to be said, but nevertheless it makes the point that these things are getting into the supply chain. And that was supplied through an OEM, so the OEM's supply chain itself was compromised. So everybody has to be vigilant. And just because something comes from an OEM doesn't mean to say you can be assured that it is compliant and not counterfeit. So what are the risks? Outsourcing. Where do your material or parts really come from? How far down through your supply chain do you go and explore? Are you really aware of where those parts come from? So that helicopter example showed that you can buy things from the OEM, but actually they still had compromised parts, counterfeit parts. So do the suppliers all the way down through the tiers hold the right approvals? Because the primes contract the tier ones, they may outsource further, and it goes down the chain until eventually a contract is awarded to an unqualified, unregulated or unapproved manufacturer. And dare I say, perhaps potentially a nefarious one who doesn't really qualify or care about the compliance or conformance of that product, simply wants to sell it and make the money. So the primes and tier ones perhaps have no visibility of this because it goes down too far through the supply chains. So lack of visibility in the supply chain is critical. How many tiers down do you go in your supplier approval process? How far do you look? What requirements do you have of your suppliers, and what do you require them in turn to flow down to their suppliers? Visibility. So we have problems of deliberate falsification of material, certification and traceability. deliberate falsification of parts history and maintenance or release documentation, bringing non-repairable parts back into service. This is why in the aerospace standards everybody is required to render beyond use anything which is deemed to be non-conforming. It's for a very good reason. So we're outsourcing so much work into those regions, and this is looking at APAC and Eastern Europe, that the propensity for risk increases exponentially. This is a statement from an FAA inspector. So it's a geographical risk that he was particularly highlighting there. An example is that helicopter crash I mentioned earlier on, where they had Chinese electronic components that somehow got into the engine management system. The inspector found, this is in a different case, the inspector found evidence of improperly manufactured parts having been installed on Boeing 777s around the world. The same subcontractor, according to the report, had outsourced other critical parts, so we don't know what they are, to an unapproved supplier. And what's more, the subcontractor had fabricated production records. So I invite you to reflect again on that 80-20 question. They identified the Boeing 777 parts. They were actually air brakes, spoilers. But what else has got into the supply chain that we don't know about? So management of the supply chain in depth is critical. And these, of course, are single point of failure parts, meaning if they fail, the whole system fails. And that's up to 500 aircraft that could be affected. So it's not an insignificant problem. There's another example, and this is perhaps showing the advantages of having suppliers who are certified. This is a 9120 audit, and it was quite a recent case. It was in the last couple of weeks. A BSI auditor asked the organisation about the supply of electronic components. The statement was, they're from the OEM, so they must be fine. I refer to my previous comment about complacency due to OEM manufacture. So they require a manufacturer's CFC. When they looked at the CFC, it was found that the OEM does not make them. Manufacture is entirely outsourced to APAC, suppliers in Taiwan, Thailand, India. So they had not identified where their parts come from. They were not considering their supply chain in depth. They were complacent in that they were taking the statement from the OEM, or the fact that they were buying from the OEM, that it must be fine. We're buying from the OEM, why should we have a problem? We require a manufacturer's CFC. That's a massive alarm bell, because they hadn't thought about the risks, they hadn't identified the risks, they were being complacent, and a fairly easy investigation identified a problem. But that alarm bell had been ignored. So when we explored it further, we found that there were no records available from the actual manufacturers in APAC. So you ask yourself a philosophical question, are they really supplying a manufacturer's CFC if they didn't make any of those parts? Do they control the change of source or the transfer of production? Are they controlling configuration? So the organisation that our auditor was reviewing had not identified or considered any of this. In other words, they hadn't looked at risk. They were complacent and they were just looking at the superficial level. And that comes down to culture. And culture comes from leadership. Some fairly recent cases that I'm sure most of you know about. Kobe Steel admits that data fraud went on for nearly 5 decades. So they were supplying steel and copper and aluminium into aerospace. And it says there, what you see is a pattern or culture. Now I have to ask, why did this not get identified? So if you look at the things the aerospace standards require, it talks about validating your suppliers, looking at their certification, but it also talks about carrying out tests on the product, the verification of purchased products. So if you're buying materials, to assure yourselves at some stage, perhaps when you're initially setting up the contract, and then with suitable frequency thereafter, to look at the chemical analysis of the materials, to check the other characteristics like the hardness, to make sure they are correct. So if those practices had been followed, arguably this would have been found much, much quicker. Kobe Steel, people trusted the name. Then another one, Mitsubishi. Why on earth would anyone question parts they buy from Mitsubishi? Global name, Japanese name, well recognized, well respected. They were making seals for aircraft. They were O-rings, in fact. So let's think about where O-rings may go. Oxygen systems, hydraulic systems for flight control systems. So you think about oxygen, the F-35 has had a few problems with its oxygen systems and barotrauma on aircrew. Now, I don't think these are related. I'm not alluding to that, but the point I'm making is that if there's a problem in an oxygen system, that can have significant effects on military aircraft or even on commercial aircraft if the crew have to go onto oxygen for whatever reason. And what if the material was incorrect, if they were sold as a Viton, i.e. oxygen compliant O-ring, but it was actually made out of some bog standard elastomer not suitable for oxygen? You've got fire potential there. Again, complacency. And a more recent case, again detected by us at an audit, we had a distributor who had provided material to an end user. That end user came back to our distributor and asked for a different material, but they wanted it from the same mill. On investigation, it was found that that mill doesn't make that particular material. But the end user was adamant that they do because they bought that material from another distributor who provided mill certs for that product. When we investigated it, we found that the other distributor, a non-certified distributor, had falsified those mill certs and provided non-conforming material to that end user. Big numbers here. 1,000 falsely marked microprocessors has got into the system. Counterfeit microprocessors, which then went to an FAA production approved organization. So they got into the supply chain. An interesting one with the A380 wheel assembly. Now an A380 has a maximum mass of something like 560 metric tons. When it lands, it hits the ground at about 140 knots. So this is to do with the wheels and the brakes. So it doesn't bear thinking about what would happen if a wheel assembly were to fail when the aircraft touched down at 140 knots with anything up to 868 passengers on board. That's its max capacity. Normally it's around the 525 level, but it can take up to 868. So somebody had allowed non-conforming wheel assemblies and brakes to get into service on an A380. So it can happen anywhere. So let's look at deliberate falsification. New parts, low-spec components made to look like high-spec ones. Counterfeiters remove the part numbers from low-spec components and replace them with part numbers of higher spec parts. So they've just got to change a number. They may not have to change the look of the item at all. They might put packaging for a higher spec component and able to sell it at a higher price. Once it's gone out of their door, they're not worried about it. They're certainly not going to be giving the money back. They can alter the overall appearance of the item to make it look like a higher quality version. Relatively simple things to do and relatively simple to detect if you're alert to the issue. And that's the question. Are we really alert to the issue? What is the culture of your supplier and their suppliers? How well do you know your supply chain? What is your internal culture? Defective parts, passed off as qualified ones, a part which may be non-conforming, a manufacturer might mark it as functioning simply to sell it. Used components being sold as new ones, counterfeits taken used components, making them look like new ones, relatively easy to do on electronics, less so on hardware. So you can see that greater risk is applicable to electronics throughout this rather than to hardware issues. And components purchased directly from unqualified businesses. We saw that earlier on when we spoke about the military helicopter. So people may not realize that further down their supply chain, there are unqualified suppliers or counterfeiters putting product into the supply chain. Anyone that's involved in the MRO side of things, this is a consideration. falsified records for used high-pressure turbine blades offered by 2 brokers, and that's the important word, broker. As soon as you see an organisation which is a broker rather than a OEM stockist and distributor, you're straight into the world of a higher risk. Brokers are different to distributors. So, falsified 8130 release forms. And when they looked at them, there was a factor of 10 difference between the hours and the number of cycles between what was actually claimed and what those blades had actually gone through. The risk there is quite clear. There have been several instances of blade failures in engines over the last few years. Again, none necessarily attributed to counterfeits, but we can think about the poor lady that was sucked out of a window on a Southwest 737 in March 2018, and an Air France A380 had an uncontained engine failure in 2017. But it shows the magnitude of effect. So people don't care. They falsify documents in order to make money, not worried about the consequences. Flap angle indicator, and this is one that was detected. So again, we're looking at the 80-20 rule. We've looked at non-detected and detected. A POA organisation in the UK identified suspect unapproved parts with forged EASA Form 1. A Form 1 equates to an 8130-3. None of the items listed on the Form 1 were recognisable part numbers. Fortunately, that was found. So that's a flap angle indicator. And there have been problems with angle of attack indicators that we know of recently. And again, I'm not suggesting for a moment that those are counterfeits, but the point is the magnitude of effect. If something is counterfeit and it fails, what might the effect be? And then there's obsolescence. Now, obsolescence is a whole subject in itself. It's a massive subject. It's inevitable and cannot be avoided, so plans must be put in place to mitigate the risks when parts become obsolete. We can think about things like the B-52, the youngest of which is 50 years old, and there are 76 in service. The discontinuation or sudden unavailability of a component part from the original source of supply due to the cessation of production, non-availability of raw materials, impacts of legislation or withdrawal or support of product support services. Risk. Unserviceable, untraceable parts may be brought back into the supply chain, or counterfeit parts may be made in some unapproved or uncontrolled manner without care about their form or function, simply making the money. So don't be fooled. And even new things have the same problem. Just because something is new, it doesn't mean obsolescence is not an issue. You buy a mobile phone, 5 minutes later there's a new model out. The phone you have in your hand is obsolete. The camera, the chips, the batteries and everything else is obsolete. So the life cycle of components, and particularly electronics, gets ever shorter. And yet with aircraft, we have life cycles of 20, 30, 40, 50 years. So what do we do about preventing these things? Refer to that statement that was made earlier on, and it picked up on 5 different things. So we're going to look at every aspect of what was in that statement. So the first thing is strong supply chain practices. So we have standards. Standards are best practice. We write standards because it helps provide business assurance. That's the business that BSI is in. So the AS9100 series defines counterfeit parts, and it defines suspected unapproved parts. So anyone that's certified to those standards or works with those standards has to be aware of them. And then they have to take steps to prevent them. And counterfeits are mentioned quite extensively throughout the standard, and I've picked out the key clauses here: prevention of counterfeit parts, verification activities, communication, and outputs. If you think about the statement that we talked about earlier on, it talked about prevention. It was weak supply chains, it was weak verification activities, poor communication, and controlling of counterfeit outputs. So these things are addressed in the standard. So there's a very good reason for you and your supply chain being certified to relevant standards. Now if we look at 9120, which is the stockist and distributor standard, that particularly picks up on unapproved parts. And this highlights the value of 9120 in that it addresses specific risks and issues that a stockist or distributor needs to address. So I would ask, why would you not insist on 9120 certification for your supply chain? And there are many stockists and distributors out on the market, and particularly there's a proliferation of brokers. If you go on the internet now, you can find a multitude of online brokers that will supply immediate AOG parts, and that they've got a big list of parts they can provide. Even eBay. eBay has aircraft parts available to buy. Now, I go to a lot of aerospace shows and events, and I quite frequently speak to these chaps when they have a stand, and I mention certification, I mention risks, I mention unapproved parts and counterfeits, and pretty much every time they look at me blankly, because all they do is source them, sell them, take their margin. So that's why brokers are a far greater risk. And it comes down to that is their culture. Their culture is, I can source it, I can sell it for a markup. I don't know much about the business. I'm not concerned about counterfeits and unapproved parts, because I have a contract which says it's not my part of the ship chief. I'm not legally liable. That is their culture. So how do you manage that risk? How are you going to manage your supply chain? Supplier approval is a critically important part of the standard. We are required by the IAQG to audit purchasing every year. And I'm often disappointed when I visit organisations to find out how poorly or superficially the supplier approval is done. We spoke about the example at the beginning of the presentation about a company that said, well, we buy from the OEM, so we must be fine. And actually, they're not. There are issues there. So supplier approval needs to be robust. So what are your criteria for supplier approval? Do you have a questionnaire that you send out, and as long as they fill it in, then somebody signs it off and you add them to the approved suppliers list? Or do you really look at it critically? Do you look at referrals? Do you look at references? Do you do research on that organisation? What do you flow down to that supplier? What do you require them to flow down to their suppliers? Do you do second-party audits? Do you require them to be certified? And it's worth noting that 9100, 9110, 9120 all talk about counterfeits and unapproved parts. ISO 9001 doesn't. The word counterfeit does not appear anywhere in the standard. So what standards do you require your supply chain to have? And how far down do you know your supply chain? From whom does your supplier buy? And the next level, and the next level. This is risk. And of course, the standards are focused on risk. Risk-based thinking should be applied to every process. The high-risk process is purchasing. So if we look at detection now, verification of goods received. Again, this is one of the things in that statement earlier on. The standard says that counterfeits part prevention should consider training and awareness and prevention. So your chaps that are doing that verification of purchased product need to really know what they're looking at. They need to really understand the documentation they're looking at. And again, the same problem I've identified when auditing organisations is I talk to the chaps doing the verification. They can count how many parts there are. They can say the part number is the same. Quite often that's about as far as it goes. Has it got CFC? Yes. Okay, let's talk about the CFC. Let's look at it in detail. Why is it not signed? Why is the part number different? Why is the date not matching? There are lots of things that they don't seem to be aware of. So training and awareness of all the people doing the verification of purchased product is critical. But more than that, everyone that uses that part downstream should also be aware. Because you may have a gatekeeper put the goods in, but that doesn't mean to say that they're going to detect things. As we all know, inspection is not 100% proof. Training and awareness. So then obsolescence monitoring program. Depending on what you're doing, you need to be aware of and plan for obsolescence. Controls for acquiring product from original or authorized manufacturers. Now that reduces your risk. Doesn't eliminate it, as we've seen, but it does reduce it. Assuring traceability of parts. How much do your people know about 8130s or EASA Form 1s or CFCs or whatever documentation you require from them? What do they know about the mill certs? What do they know? How do they tell a good mill cert from a counterfeit mill cert? And what verification methodologies are you going to apply? And the question there is, well, what are the risks? And therefore, what do I need to do about it? We mentioned materials from Kobe or from Mitsubishi, which were counterfeit or didn't meet the requirements. Had people conducted suitable tests, hardness tests, chemical analysis, and so on, arguably those would have been detected. So you identify the risk and you put in place methodologies suitable to confirm that those parts are conforming. Monitoring of counterfeit parts reports from external sources. Again, it was in that statement. And the industry is getting better. And I'm going to show you a whole load of websites a bit later on to help you out. But EASA lists SUPS reports, FAA has them, the UK government has reports. There's lots of things, lots of sources of information that you can use to keep up to date with reports of counterfeit products and materials. How many of your purchasing managers or process owners are aware of those, monitor them, and identify issues and flow it out to their verification people at the control point at entry? And then quarantine and reporting of suspect or detected counterfeit parts. They should be reported, because those websites that I mentioned that share that information, if nobody reports, then there's nothing to share. And detection is arguably the biggest risk is in electronics, but all parts and materials need to be verified and counterfeits prevented. So if we look at mill certs, falsified mill cert used the stockholder logo instead of the steel mill. So let's have a look at that. This is one I got from the net to give you an example. So this was on the company's website. So it's useful to look at these organizations and their websites because they want to prevent counterfeits as well. So this was a mill cert, but the logo was for the stockholder, not for the mill cert. So straight away you could tell, if you know what you're looking at, that it's not a genuine mill cert. Because they are EN 10204, then it should also have an EN 9001 reference. So that wasn't true. So this comes down to your goods in people knowing your suppliers, knowing the relative standards that are being applied by that supplier, and being able to identify when something is not right. Classification society stamps, Lloyd's Register, DNV, TEV, and so on, not missing. So these are examples of things that were found on a mill cert that could easily have been detected to prevent non-conforming product being received into your supply chain. The kind of indicators your team should be looking at, again, this is not an exhaustive list, but it's a good indicator. Wrong logos, wrong letterheads, vague certification, facility not authorized, so have they got the correct approvals? Unauthorized signatures, signature of someone who doesn't exist in that organization. There's nothing wrong, if you're not sure, with contacting the organization and asking them about a document or a person. Illegible signatures, dates on documents, dates that don't tie up with the shipments, changes in ink, typeface, font, life limits not correct, double sets of non-identifiable records, document data inconsistent with the part condition, cut and paste, that's an easy one, it should be easy to find, whiteouts on documents, and that would also tie in with misalignment of documents if you've got a line of text and it's slightly out of line or off center. So all these things are things that your team should be aware of and looking at, particularly when they're doing verification of documents provided with your bought-in product. And this was I thought this was amusing to bring to your note because it had a document that said there was a 96-ton plate. Now, that might be nice to do, but I suggest handling a 96-ton plate would be rather difficult to do. So that was a fairly obvious indicator of a counterfeit product, and that was on a stockholder's website. We mentioned approvals earlier on, and here's an example of some bushings that got into the supply chain from a non-production approval holder. That should have been easy to identify. If the person doing the goods in is looking at the documentation and verifies the approvals held by the origin of those parts, they should have been able to identify that they were non-conforming, they're unapproved parts. So visual examination of the packaging, the labels and documentation. Is there any misspelling, any misalignments, changes of letters, dates that don't match, dates too far in the past or even, and it has happened, dates in the future, And is the packaging correct? Does it have what you would expect for that product? Moisture absorbing silica, for example, humidity indicator cards. Is the same font used as by the OEM? Is the country of origin correct? All these things your chaps at the goods in, your gatekeeper, should be familiar with and able to look for. And then looking at the part itself. Now, a couple of things on electronic parts. If it's a circuit board, quite often they have indents on them. And these should be uniform and clean circles, consistent depth, even across the product. The counterfeiters have to remove some of the marks, so they sand them down and then recoat them, and it's a process known as blacktopping. So the indents will no longer be consistent depth and consistent distribution. And you can use an acetone wash, for example, to try and remove false printing or identify false printing. And you can look under a microscope and look at the sanding marks. And if you really are concerned, you can X-ray components to look at the genuine internals compared to counterfeit internals. So there are various techniques you can apply based on the risk and the level of concern. Electrical testing seems pretty obvious. How about a sampling process? And then decapsulation. Now this destroys the product, so you would use it if you had a particular concern, but you can decapsulation, i.e. open the thing up, and microscope examination of the internals to look at the components. The simpler things, look at the thickness and the edge finish. Has it been altered by sanding? Use a microscope to see the sanding marks. You might have it's very easy to have a little ×50 magnifier in the goods in, so that they can look at the surface of the product. Correct spacing of the pins, oxidation, scratches, all these things are indication of either counterfeit parts or things which have been brought back from the dead. So we mentioned some sources of information. Again, this is not a definitive list, but these are things to help you, things you can apply depending on what you do to help your organization and share that information. First of all, so of course, there's the 9100 series, which, as I said, mentions counterfeits a lot, but it also focuses on risk. I think the word risk is in the AS9100 standard something like 70 times. So in everything you do, in every process you do, every activity you do, you should be saying or asking yourself, what are the risks? How am I going to manage those risks? And in the case of purchasing, how am I going to apply that to my supplier evaluation, to my supply chain? How far down through the supply chain do I go? Am I going to be complacent because it's an OEM supply, or am I going to really be conscientious and look further? And then we have specific standards to help specific things. AS553, AS6081, ARP6328. All these are looking at particularly electronic components. So it shows that, again, the risk, or the greater risk, is in the electronics. It's easier to counterfeit or bring back from the dead old parts. So there's a whole raft of standards there which can be applied if applicable, and you can implement them, you can train your people in them, and use those standards to give yourself assurance that what you're buying is conforming. And then we have ISO standards, authenticating solutions to combat counterfeit goods, guidelines to deter counterfeiting and illicit trade, ident systems, and then we ISO 20243. If you're buying commercial off-the-shelf ICT products, how do you know that software is not counterfeit? There's no visible signs for that. And then IEC, avoiding the use of counterfeit, fraudulent, recycled electronic components. So there are lots of standards out there which are pertinent and which you can use and should be aware of and should have implemented if you are looking at verification of purchased product to prevent counterfeits getting into your value stream, your supply chain. And then there's the military side of things. Now, you may or may not be supplying into the military, but they have good practices. So if you're supplying to the military, no doubt you'll have to comply with these. But if you're not, there's no reason why you can't look at these and take some of the things out of it for best practice, irrespective of your sector. So there are US MIL standards. The UK has Defence Standards 05135. There are various Department of Defence manuals. Again, not an exhaustive list, but this is an indicator of things you can use to apply in your systems as part of your controls. And then, of course, there's the regulatory side of things, Part 21, Part 145, etc., which I'm sure we're all familiar with. And there's the military side, DFARS, and in the UK you've got the Military Aviation Authority. One of the things that was mentioned in that statement right at the beginning of the presentation was communication between suppliers and users. And here are some websites where that information is shared. So the Government Industry Data Exchange Program, GIDEP, shares that information. EASA has its list of suspected unapproved parts. There are safety information bulletins from EASA. The FAA has Order 8120-16, which is to do with SUPS control, and there's a website about the SUPS program there. And they have UPNs, unapproved parts notification. So there is that communication between users and suppliers and those interested parties, stakeholders. But of course it's only as good as the reporting system. So I would urge you not only to have robust systems for detection and prevention of counterfeits, but if you do find them, tell somebody. Report it to the appropriate organisation or organisations so that that information is shared to the good and benefit of all. Ultimately, of course, we're all stakeholders. I would suggest everyone on this website probably flies at some time, so we're all stakeholders in this. The IAQG, the International Aerospace Quality Group, has a supply chain management handbook, which is a free online resource, and that too has extensive useful information on supply chain management. It's an underused resource. It's full of very good data, not just about supply chain, but every aspect of managing a QMS. So I would strongly commend it to you to go and have a look at that. The UK government did a report on counterfeiting in ASEAN. That's a worthwhile report. So hopefully some of these links you will be able to look at later and take some useful information from them and start applying them into your systems. And here's an example, excuse me, of an FAA UPN, unapproved parts notification, avionics system, again, electronics. So these are the affected parts. And you can see this is 2018, so it's quite a recent one. So that information is out there. You've got to be aware of it. You've got to know where to find it. You've got to look at it and then share it amongst your team if it applies to you. And importantly, if you find counterfeits, do please report them. So let's have a quick look at some best practice items, a quick summary. Application of risk-based thinking. What are the risks? How will you manage them? We've looked at some of those risks. We've looked at outsourcing. We've looked at geographical risks. We've looked at the types of products where risks are arguably higher than others. So electronics is a higher risk perhaps than hardware. And then I would look at training. Training of your gatekeepers, training of everybody who then uses or handles that product, because as I said earlier, gatekeeping is not 100%. If everybody is aware, then somebody some stage may just detect that this C of C is not quite as it should be. There's an error in the text. There's a date which doesn't stand up to scrutiny. This font does not align with the others. It's a different font. So training, in-depth, thorough, focused, and current. And for that to be effective, you need to have the right culture. Everybody needs to be mindful. They need to be aware and they need to be engaged. So I would really urge you to focus on culture. And of course, culture comes from leadership. Leadership is critical in this. And this is why the aerospace standards and indeed the ISO 9001 standard talks about leadership and then strategy and then communication. Because to get an engaged team, an aware team, a team which is mindful, and a team which positively works to the greater good, you need that leadership. The best example of a leadership failure is a very sad one. There's an investigation, Haddon Cave, he's a judge. It was an investigation of the crash of British military Nimrod reconnaissance aircraft. many years ago in Afghanistan. You can download that from the internet if you look up the Nimrod. If we Google Nimrod or Haddon Cave Nimrod, you'll find the report. And the summary says that ultimately it was poor leadership. And the people that were working under that leadership and direction were not mindful. They weren't engaged. They paid lip service. They went through the motions of doing the safety case, but didn't really do an honest day's work on producing the safety case. So if you translate that into your supply chain, your supplier selection, supplier monitoring, your verification of purchase product, exactly the same applies. If you want a workforce that is engaged, aware, mindful, then you need the culture, and the culture comes from the leadership. Parts obsolescence management, you need to be aware of, again, depending where you are in the supply chain and what you do, how are you managing that obsolescence program? Robust supplier evaluation and management. How far do you need to go? Don't be complacent. Don't be overconfident. Don't assume that because you're only buying from an OEM that all is well. I've given you several examples of OEM products which actually weren't conforming. Arguably, the OEMs could or should have detected those themselves. But at all stages in the supply chain, we're all equally responsible for preventing those counterfeits. So don't be complacent. Back to culture again. Don't assume. Don't take it as a given that things are correct. How far down do you need to go into your supply chain? What are the flow downs that you're going to put down to your supply chain that they have to put down their supply chain? Then on to the gatekeeper, the thorough and effective verification process. For that to be effective, the people need to really know what they're looking about. We've covered the training. They need to be aware of all the potential issues, the potential clues or indicators to counterfeits, and they need to be current, so they need to be kept up to date. So monitor those websites. Look at the ARSA and the FAA and the GuideApp websites. See what's new, what's coming through. And that's where the currency comes in. Look at the latest sources of information. Keep your key team up to date. And then finally, quarantine or destroy any counterfeit or suspected counterfeit parts or non-conforming parts, and then report them up the chain. Because all those sources of information are only good, only effective, if we all engage and report it. The item I mentioned earlier on with the non-conforming material, which was provided into the supply chain because there were two distributors, one of which falsified some documents. I reported that to the CAA because it was of sufficient import for me to report that. So we're all part of this supply chain. So that's the end of my presentation. I hope you found it useful and informative. We have a few minutes in hand, so should there be any questions, I'd be happy to take them. Okay, let's have a look. Robert Tipton, what is the likelihood of 9120 changing counterfeit issues from consideration to requirement to address? I think it's probably just the wording in that you have to consider it. So in effect, it is a requirement. If we were auditing a 9120 organization and they hadn't considered those things, then we would take a very poor view of their application of the requirements of the standard. Next question, training requirements within 9100 require a follow-up validation of effectiveness. If we use this webinar as a training tool, do you have the ability for such a follow-up sign-off? I think the answer to that would have to be no. I don't think I would be able to validate any learnings you might have from this webinar. This webinar is something to help you and your organizations identify the risks, the concerns, the strategy that you need to employ. And therefore, it would have to be from your own organisation, I think, that would have to validate and sign off any training based on this webinar. This webinar is an overview. So I hope that answers your question. Does anybody else have any other questions? In which case, I thank you all for your attention. If you do have any questions that occur to you later, then by all means do please contact BSI and we'll see what we can do to help you out. And I shall now hand back to my colleague, Lucas.
Thank you very much, Brendan. And we also want to thank our attendees for attending BSI's web conference. You can anticipate our follow-up email within the next 7 to 10 business days, which again will include a link to enroll in today's recording. Please complete the survey to provide feedback and future ideas for webinars, which will pop up after this conference concludes. And be sure to join us again. Visit our website to view upcoming webinars at bsiamerica.com/events. Thank you very much for joining, and goodbye.